Your Dataverse is a database. That is the assumption most organizations are still working with, but in reality that assumption is broken. What Dataverse is actually becoming is something else entirely. It is turning into an orchestration layer, a context engine, and the connective tissue between your AI systems and everything your organization knows. Most organizations have not noticed this shift yet. They are still building custom API wrappers to connect systems the same way they did 5 years ago, where you build a connector and then maintain it forever. That model worked when integration was a point-to-point problem, but AI changes everything. Here is what is happening right now. Organizations are discovering that the custom connectors they built, the ones they thought solved their integration problem, are actually becoming a bottleneck. Every new AI tool means building a new integration, and every new platform means rewriting the connector logic. The maintenance costs keep climbing, yet nobody is keeping score. By the end of this episode, you will understand why custom integration is becoming technical debt. You will see what is replacing it, and you will know exactly what to do about it in your organization. The legacy model. Why custom integration became the default. Go back 20 years. Integration was a real problem. You had SAP over here, you had Salesforce over there, and maybe some legacy mainframe system that nobody fully understood anymore. None of those systems talk to each other. Custom connectors solved that. Developers built bridges by writing an API wrapper, adding some error handling, and throwing in some retry logic. It worked. The systems talked, data flowed, and problems got solved. This was not a stupid solution. It was pragmatic and necessary. In a world where systems were built in isolation, custom integration was how you made things work together. But the model had a structural flaw, and nobody saw it coming. The flaw was this: every new system meant new code. Every new AI tool, every new platform, and every new consumer of your data meant building another custom connector. You had to implement authentication again, you had to figure out the schema again, and then you had to test it, document it, and maintain it forever. The fragmentation tax started accumulating silently. By 2024, most enterprises had built hundreds of custom integrations. It did not happen by intention, it just happened. A team needed Salesforce data, so they built a Salesforce connector, and then another team needed Salesforce data connected to ServiceNow, so they built that bridge. Then someone else connected it all to Azure, and the web of custom code grew. Each connector was a liability. Each one had dependencies nobody fully documented. Some were maintained while others were not, and some had security holes that nobody knew about. As people left organizations, the knowledge of how these connectors worked left with them. The real cost was not the initial build. It was the maintenance tax. Organizations discovered they were spending 300% of the original integration cost just keeping these things running over 2 years. They were updating them when underlying systems changed, fixing bugs, responding to security issues, and patching dependencies. But here's what is important. Nobody framed this as a problem. It was just infrastructure. It was how integration worked. You built connectors, you maintained them, and that was the job. The assumption was always the same. Build an API wrapper and maintain it forever. If you needed a new integration, you just built another wrapper and added it to the pile. This worked fine when integration was a one-time problem where you connect system A to system B, but it breaks down completely when you are connecting one system to 50 different AI tools, especially when each of those tools might change its interface next quarter and you need to move fast. That is where the model breaks. That is where everything changes. The flaw exposed: why custom integration fails at scale. Now, take that single problem and scale it across an entire enterprise. You have 10 different systems like SAP, Salesforce, ServiceNow, and Azure, along with legacy applications and HR tools. When you use custom connectors, you don't just have 10 problems to solve. You actually have 10 systems multiplied by every team that needs that data, which creates a massive web of connections. Maybe 3 teams are pulling from Salesforce while 5 others need SAP, and 2 more want real-time access to your data warehouse. The math gets ugly fast because you aren't building one bridge to Salesforce, you're building 3. Instead of one SAP connection, you're managing 5, and suddenly those 10 original problems have turned into hundreds of individual points of failure. But here's the problem nobody talks about. Every single one of those connectors is slightly different. The Salesforce connector built by the first team looks nothing like the one built by the second, and they use different error handling, different security rules, and different assumptions about the data. If a security flaw is found in one, you have no idea if the others are at risk. When an underlying system changes, you won't even know which connectors are broken until they start failing in the middle of a production run. Shadow AT doesn't even begin to describe this mess. It is integration sprawl, and it represents a massive amount of organizational debt piling up in the infrastructure where nobody is looking. Security teams are usually the first ones to hit the wall. A security engineer might ask a simple question about where customer data is flowing, which is a reasonable thing to want to know. But instead of a clear answer, they spend 3 weeks tracing custom code through a dozen systems. They find one connector written in Python, another in C++, and a third that is just a scheduled PowerShell script running every night. Some are hidden inside undocumented Power Automate flows, while others are hard-coded on a laptop and pushed through DevOps. The reality is that they can't govern what they can't see, and right now they are completely blind. Audit trails are just as scattered. One connector might log to Azure, another to application insights, and a third to a file share that nobody has checked in months. If data leaks or someone abuses their access, trying to piece together the timeline takes weeks, and even then, you probably won't have the full picture. Then the AI tools start showing up. Your company decides to connect Claude to Dataverse, so someone builds a custom connector to make it happen. 6 months later, another team wants to use ChatGPT with that same data, but they don't know the first connector exists, so they build a second one. Now you have two different versions of the same thing, each with its own security risks and maintenance needs, and both of them are invisible to the people in charge of governance. This is the moment organizations realize they aren't building integrations anymore. They are building integration debt. The debt starts small with a few hundred lines of code that one person understands, but it compounds every time a new system or user is added to the mix. Every quarter that passes without documentation makes the pile bigger, and every time a team member leaves, they take the knowledge of how to fix it with them. After 5 years, you aren't maintaining a system. You are performing archaeology. You're trying to figure out why everything crashed at 3 a.m. by reading code that nobody understands anymore, which is connected to systems that have changed 3 times since the script was written. The team that should have deployed AI automation in weeks is now spending months just trying to figure out which connectors are safe to touch. Security can't track the data, architecture can't see the landscape, and the cost to keep it all running is becoming astronomical. That is what happens when you try to scale a broken model. What is the Model Context Protocol? Before we go further, you need to understand what MCP actually is. It isn't a database, it isn't another API, and it isn't a traditional connector. MCP stands for Model Context Protocol. At its core, it is a standardized way for AI systems to discover and use the tools you already have. The big idea here isn't just about how to fetch data, but how to let an AI see what is available, understand what it can do, and perform tasks without needing custom code for every single scenario. Anthropic introduced MCP in late 2024, and within just a few months, it was adopted by OpenAI, Google, Microsoft, and Amazon. This happened because every major AI vendor realized they were facing the same infrastructure nightmare that ruined the API world. They knew that if they didn't create a standard early on, they would end up with total chaos later. The way it works is actually very elegant. One MCP server shows a set of tools that are described in a standard format. Any AI client, whether it's Claude, ChatGPT, or GitHub Copilot, can connect to that server and automatically see what tools are there. It understands what each tool does and how to use it immediately. You don't need a custom integration for every client because you have one server serving many different AI tools. Think of it like USB-C. For a long time, every device had its own specific charging cable, so your phone, laptop, and tablet all needed something different. Then USB-C arrived and gave us one standard plug that works for everything. You no longer need a different cable for every device because the standard ensures they all play together. That is exactly what MCP is doing for AI and enterprise software. Under the hood, MCP uses a lightweight protocol called JSON RPC that can run over almost any connection, including HTTP or WebSockets. The specific way the data travels doesn't matter as much as the protocol itself. It provides a standard way for tools to describe themselves, a standard way for AI to find them, and a standard way for the tools to report back what happened. This solves a massive problem that custom connectors never even touched. A custom connector only solves the problem of moving data from point A to point B, but that is only half the battle. The harder part is discovery, because the AI needs to know what is available and what operations are actually safe to perform. It needs to know its own permissions and understand exactly which data it can access and which it can't. Custom connectors usually bury those details in documents that nobody reads, or they don't record them at all. The AI gets connected, but then it has no idea what it's allowed to do. It doesn't know the shape of the data, and it doesn't know if it's about to trigger a massive financial transaction or just read a simple file. MCP makes all of that explicit. The server tells the AI exactly which tools are exposed, what parameters they need, and what security rules are in place. Now, the AI system can actually understand its own boundaries. It knows what is in scope and what is off limits. That is the real structural shift. It isn't about better network speeds or faster APIs. It is about better discovery and better constraints that allow AI to move fast while staying completely safe. This is the change that is going to redefine enterprise integration forever. The Dataverse MCP connector, what changed? Microsoft took this standardized protocol and did something very specific by building a dedicated Dataverse MCP server. In practical terms, this means Dataverse is no longer just a static data repository that requires custom code to reach. It has become a first-class citizen in the MCP ecosystem, which changes how every AI agent interacts with your business data. Whether you use Claude, GitHub Copilot, or any other MCP-aware client, these tools can now connect to Dataverse and automatically discover what operations are available. They understand the governance around those operations and can use them immediately, all without you ever building a single custom connector. To make this concrete, we should look at how things worked before MCP changed the landscape. If you wanted an AI tool to access Dataverse data in the past, you had to write a REST API wrapper or a custom connector from scratch. You were responsible for handling authentication manually and deciding exactly which tables that wrapper could touch. You had to write the error handling, document the API contract, and bake assumptions into the code about who could do what. Once that was finished, you still had to deploy it, test it, and maintain that code forever. The problem got worse when you wanted to add a second AI tool to your workflow. You would usually have to build another wrapper with the same logic but slightly different scaffolding to satisfy a different authentication flow. This led to different assumptions about what data to surface and documentation that often contradicted the first wrapper in subtle, frustrating ways. The Dataverse MCP connector replaces that entire broken workflow with something much simpler. You install a local proxy, configure your tenant ID, and point your AI client at that proxy to get everything running. The proxy handles all the discovery and understands the Dataverse security model so it can translate between what the client needs and what the platform provides. Every client that connects to the system gets the same behavior, the same security constraints, and the same permissions model every single time. This shift matters because the security model in Dataverse is incredibly sophisticated. You have security roles, field-level security, and business units that all work together alongside organization-level settings to determine who can see what. A custom connector either respects all that complexity, which means you have to implement it yourself in code, or it doesn't, which means you've accidentally created a massive security bypass. The Dataverse MCP connector doesn't bypass your governance because it actually flows through it. When an AI agent connects through MCP, it operates under the specific permissions of whoever initiated that session. The security roles apply, the field-level security applies, and the business unit boundaries remain fully intact. You don't get a special AI connector security model that's weaker than what a human user has, but instead you get the same constraints and audit trails you already trust. This represents a fundamental structural difference in how we handle integrations. Most custom connectors require security teams to accept a lower bar because they promise to restrict access on the application side. They claim they will make sure only trusted tools can call the API, but that is always a weaker model than the built-in security Dataverse offers. With MCP, you aren't creating a parallel security model that your team has to manage, but you are finally using the one you already built. Setting this up is genuinely straightforward for any team. You download the Microsoft Power Platform Dataverse MCP tool from the standard package repository and install it locally or in a container. After you give it your tenant ID and connection information, you simply start the proxy. Then you configure your AI client, like Claude Desktop or GitHub Copilot, to connect to that proxy and start working. That is the entire process. Now Claude can talk to Dataverse, GitHub Copilot can access your CRM data, and any MCP-aware agent can work with your business data. Every single one of those tools uses the same security model and the same data governance while leaving behind the same audit trail. But we need to be clear about what is actually happening here. This isn't just a convenience upgrade where you only have to build one connector instead of 5. That is a small tactical benefit, but the strategic benefit is much larger. The real shift is that Dataverse becomes an AI-ready platform without requiring custom code for every new use case. You don't need a separate integration for Copilot or a different one for Claude or a custom connector for whatever new tool appears next quarter. The platform itself is ready, the data is discoverable, the permissions are clear, and the audit trail is automatic. This is what true restructuring looks like. The performance reality, why MCP is slower, but it doesn't matter. There is something you need to hear early before the enthusiasm for this technology builds too high. MCP is slower than direct REST calls when you look at raw latency and pure speed. If you measure the milliseconds per request, a custom API integration is going to win every single time. The JSON RPC protocol adds overhead because every call has to go through an extra hop. The MCP layer sits between the client and the underlying system where it translates requests, unpacks responses, and manages the conversation. Those milliseconds add up quickly, and benchmarks show that you are looking at a performance hit of 15 to 25% compared to hitting a REST endpoint directly. That isn't a trivial difference, and in certain environments, it is a very real problem. For some systems, this latency matters deeply. If you are running real-time trading systems or millisecond-sensitive financial operations, you can't afford that extra weight. High-frequency data streams where every 100 microseconds of latency compounds into a real cost require the fastest path to the data. In those cases, custom integration and direct API calls are still the right answer. But here is what is actually happening in your organization. You probably stopped measuring latency and caring about request milliseconds sometime around 2018. What you are actually optimizing for now has changed completely. The real metric today is the cost per decision. We aren't looking at milliseconds per call anymore, but rather the cost per AI-driven outcome. You should be measuring the time it takes to go from having a business question to having a working answer implemented in your workflow. This is where the conversation about performance completely changes. MCP can cut your language model token usage by 50 to 80%. That isn't a typo, but is actually the documented range for these types of implementations. The reason for this is straightforward because with a custom REST connector, you have to stuff every detail into the prompt. You give the AI model a schema, hand it a list of endpoints, and explain what each one does while hoping it figures out which parameters to pass. The AI has to hold all of that in its working memory, which burns through tokens just to understand what is available to it. Dynamic schema serving changes that dynamic entirely. MCP lets the AI ask what is available as it goes, so it doesn't need to memorize the entire schema at once. The server gives back only what is relevant to the current task, which means the AI gets smaller, focused context chunks instead of a giant information dump. This results in fewer tokens and a much more efficient process. When you look at this at scale, that is where your actual costs live. It isn't about milliseconds per request, but token consumption per operation. If you run 1,000 AI operations a month through Dataverse, the difference between token-efficient and token-wasteful integration adds up to thousands of dollars. But there is something deeper happening here than just saving money. You aren't just optimizing for token cost, but you are optimizing for what is actually possible to achieve. With custom connectors, the AI doesn't really discover what is available because it is just reading a document and guessing. With MCP, the AI knows exactly what tools exist and what permissions govern them because the server tells it directly. That means the AI can operate with much more autonomy, it can attempt operations it wasn't explicitly trained for, and chain tools together in novel ways. It can reason about what is possible and what isn't without constantly asking a human for permission or clarification. This is the structural point I want to emphasize. Yes, MCP adds latency, and for bulk operations moving terabytes of data, you should still use REST. Direct calls win for high-throughput tasks. But for AI-driven discovery and autonomous agents that need to understand their own constraints, MCP wins decisively. The slowness is simply the price of capability. It is a trade you should be willing to make. And when you look at the economics, you aren't really trading anything at all. The economics. Why organizations are retiring custom connectors. Let's talk about what actually moves decisions inside an organization. It isn't the architecture or the governance frameworks. It's the money, the time, and the spreadsheet that gets presented to the board. Organizations are retiring custom connectors because the economics are undeniable. Start with implementation time. If you want to build a custom API wrapper so an AI tool can access Dataverse data, you should plan for 4 to 8 weeks. That is the industry standard. You need an architecture review and a security assessment, then you have to handle development, testing, and documentation before you even think about deployment. 8 weeks is actually being optimistic for anything meaningful. Now add a second AI tool. You have to repeat that entire process for another 4 to 8 weeks. Maybe the authentication mechanism is different, or perhaps the error handling and schema mapping require a new approach. You are looking at another team and another budget cycle for another 2 months of work. With Dataverse MCP, that second AI tool takes days, not weeks, days. The MCP server already exists, it already handles authentication, and it already understands the Dataverse security model. You simply configure the new client to point at that server and run a quick test. That is not a minor difference, it is an order of magnitude. When you multiply that across an entire organization, the scale of the problem becomes clear. If you have 5 new AI initiatives queued up, custom connectors turn that into a 40-week project at minimum. It will probably take 50 weeks once you account for rework and interdependencies. With MCP, that same workload takes a couple of weeks total. This allows your team to spend their time building actual AI experiences instead of fixing infrastructure plumbing. But implementation time is just the beginning. The real economics hit when you look at the maintenance burden. Every custom connector you build requires ongoing care. When Dataverse adds a new field to a critical entity, you have to search through your entire portfolio to find out which connectors just broke. When a security vulnerability is discovered in the REST API layer, you have to audit every single connector one by one. If the team member who understood how a specific connector worked leaves the company, that knowledge walks out the door with them. Each custom connector is a point of friction and a place where things can fail. It is a dependency that needs constant monitoring and an artifact that needs updating every time the underlying systems change. If you multiply this across 50 or 100 custom connectors, you create a maintenance burden that grows faster than your development team can handle. Dataverse MCP inverts this model. You maintain one server, one codebase, and one set of security policies. There is only one audit trail to follow. When the underlying systems change, you update the MCP server once, and every client automatically gets that update. You no longer have 50 different implementations to fix. The early adopter data tells a very clear story. Organizations with 20 to 100 Power Platform developers are reporting monthly MCP consumption costs between $200 and $800. That is the entire infrastructure cost to provide AI access to Dataverse across an entire development organization. Now compare that to the alternative of maintaining custom connectors. One analyst estimates the fully loaded cost of maintaining a single enterprise integration at about $15,000 per year. That includes salary, infrastructure, testing, and security reviews. If you have 50 custom connectors, you are spending $750,000 annually just to keep the lights on. The math gets worse over time. The first connector costs money to build, and the maintenance tax starts small, but then it compounds. Every year, more teams touch it and more complexity accumulates. By year 3, you are spending 3 times the original build cost just to keep that one connector alive. And this is why organizations are retiring custom connectors. It isn't for philosophical reasons or because they discovered MCP is theoretically superior. They are moving because the economics of the old way are brutal. With custom connectors, your AI integration cost rises exponentially. Every new tool and every new system multiplies the burden until the cost curve accelerates out of control. By the time you realize there is a problem, you have built an infrastructure that is expensive to maintain and nearly impossible to change. With MCP, your integration cost stays flat. You have one server and many clients, which means your overhead is fixed. The cost per new AI initiative approaches zero because the only variable is the complexity of the use case, not the plumbing. That is why organizations are moving. The governance gap, why DLP policies don't cover MCP yet. A massive gap is opening up in enterprise governance right now, but the problem isn't the model context protocol itself. The issue is how your organization's existing security controls actually handle it. Your data loss prevention policies exist for a very specific reason. They protect sensitive information and prevent customer data from flowing to unauthorized SaaS platforms, while also stopping intellectual property from leaking to your competitors. These policies enforce compliance requirements around financial data and health information, and because they've been battle-tested across thousands of organizations, they generally work. But in reality, they don't see MCP. Your current DLP policies are built to understand connectors, so they check the Salesforce connector or the SharePoint connector and block the Dataverse one. They understand flow actions in Power Automate and know exactly which SaaS applications your organization is allowed to integrate with. These systems have full visibility into your approved and blocked vendor lists because they work through pattern recognition. If the system sees a Slack connector, it applies the Slack policy, and if it sees Outlook, it applies the Outlook policy. MCP servers simply don't show up in that taxonomy. They aren't Slack or Outlook, and they aren't a named SaaS vendor with a pre-built connector that your security team can easily identify. An MCP server is a generic protocol endpoint that could expose almost anything, ranging from legitimate business data to a misconfigured server that's leaking more than it should. Your DLP policies can't distinguish between these cases because MCP servers don't match the patterns your security rules were built to recognize. This isn't a flaw in the protocol, but it is a major gap in how organizations govern AI-driven data access. Nobody actually planned for this because most DLP policies were written years before MCP even existed. The people who designed your policies didn't account for a standardized protocol where AI agents could discover and use tools dynamically. They built their controls around known platforms and integration patterns, and now MCP is breaking every one of those assumptions. Microsoft is aware of this problem, which is why they are currently building advanced connector policies. ACP is supposed to be the definitive answer because it's designed to understand MCP servers specifically and see them whenever they are in use. The goal is to give security teams governance over what an MCP server can expose and who is allowed to use it. In theory, the logic is solid, allowing you to define policies at the MCP level so you can permit one server while blocking another. You could even specify that a tool within a server is available for finance teams, but completely blocked for anyone on an external network. That's the theory, anyway. The real problem here is timing. Since ACP is still in preview as of early 2026, it isn't generally available for most users yet. This means if you're deploying Dataverse MCP today, you're putting it into an environment where your security controls are essentially blind to it. You can't govern it through your standard DLP policies, so you have to build manual workarounds like restricted access lists and governance workflows that sit outside your normal framework. Even when ACP finally reaches general availability, it has a limitation that security teams are already starting to grumble about. You can block an entire MCP server or you can allow it, but granular control over individual tools within that server is a feature that's coming later. Right now, it's an all-or-nothing choice at the server level. Think through what that actually means for your operations. If you've deployed an MCP server that exposes 10 different tools, and one of them accesses sensitive HR data while the rest are low-risk support queries, you're in a tough spot. With current ACP capabilities, you can't allow the support tools while blocking the finance operations, so you're stuck choosing between shutting down the whole system or allowing everything. This creates accountability problems that shouldn't exist in a professional environment. When an AI agent acts through an MCP server, the audit trail shows the human user who started the session, but it doesn't show the agent or what that agent decided to do. You can see that Sarah opened a session and data was accessed, but you can't see if Claude decided to pull customer financial records on its own. You have no way to tell if Sarah instructed the AI to do that or if the agent made that decision autonomously. That's a massive governance problem and a total lack of accountability, which is exactly why this gap matters so much. Your security team simply cannot govern what it can't see with the right level of detail. The identity problem. Who is responsible for AI actions? In the old integration model, the identity trail was always clean. When an API call came from somewhere, that source had a name like a service account or a specific user ID. You followed the trail and knew exactly who or what made the request because ownership was explicit and responsibility was clear. The audit log would show that a specific identity called an endpoint at a certain time with specific parameters. If something went wrong, you had a clear starting point and an actor you could hold accountable. You could revoke their access or retrain the responsible party because the entire accountability model worked on the idea that identity was never a mystery. MCP breaks that model completely. Here is what the process looks like now. A human user starts a session and connects to the Dataverse MCP server through an agent like Claude or GitHub Copilot. The agent then starts working by discovering available tools and reasoning about which operations will accomplish the user's goal. It invokes a tool, data moves, and suddenly a sensitive customer list is pulled or a financial transaction is queued up. The audit log records the timestamp and the result of the operation, but it attributes every single action to the human who started the session. It doesn't mention the agent or the system at all. It only mentions the human. This creates what security professionals call an attribution gap. You might see that Sarah opened a Dataverse MCP session at 2:15 p.m. on Tuesday and that financial records were accessed 2 minutes later. The records show a data flow that should have never happened according to your security policies, but the audit trail can't answer the most important question. You don't know if Sarah intentionally decided to export that data or if the AI agent pulled it autonomously because it thought it needed the information. This matters for more than just internal rules, as it impacts regulatory accountability and legal liability. You need to be able to prove who authorized a sensitive operation for your compliance certifications. If Sarah intentionally pulled customer data she wasn't supposed to see, that's a clear security incident and a violation of your policies. You would need to investigate the situation and likely terminate her access immediately. But if Claude decided it needed that data to answer a question and pulled it without Sarah realizing what was happening, you have a completely different problem. That's a system failure where a permission boundary wasn't enforced, and it points to a governance issue with the MCP server itself. In that scenario, Sarah might have done nothing wrong, while the agent acted way outside its intended scope. The audit trail doesn't tell you which of those things actually happened, and that kind of ambiguity is dangerous for any business. Microsoft's proposed answer is Entra ID agent identities. The idea is pretty straightforward because instead of attributing operations to the human user, they get tagged to the agent itself. Claude gets its own identity in your Microsoft Entra directory, and GitHub Copilot becomes a first-class security principal. They can be assigned their own permissions and audited separately so their actions show up in the log under their own names. This solves the attribution problem by letting the audit log show exactly when Claude accessed records and what parameters it used. You can finally govern the AI separately from the human user and enforce different permission boundaries for different agents. This allows you to see what each agent is authorized to do and compare it against what it actually did in the system. The problem, once again, is the timing. Entra ID agent identities are still in preview as of the first quarter of 2026, so they aren't generally available yet. Organizations that are deploying MCP today don't have this capability, which means they have to find other ways to manage the risk. Most of these workarounds aren't very elegant. You might use approval workflows where sensitive operations require a human to click confirm before anything happens. Some teams use human-in-the-loop gates or detailed logging of agent reasoning so they can try to reconstruct why a decision was made. These are just compensating controls that work well enough, but they are far from perfect. This is the exact point where technical problems turn into organizational problems. You can't just deploy MCP and hope your governance works out on its own. You need explicit policies for how AI agents should behave and a clear separation between what agents can do and what humans can tell them to do. You need audit trails that capture the intent behind an action rather than just the action itself. Until those Entra ID agent identities are ready for production, you need interim controls that slow things down enough to keep everyone safe. This is why your governance teams need to start thinking about MCP in a completely different way. The security implications, MCP as a new attack surface. But there is something else happening right now, and it is a shift that gets far less attention than it actually deserves. MCP servers are becoming high-value targets for anyone looking to break into your systems. Think about what these servers actually expose to the world. They reveal your business logic, your data access patterns, and exactly what operations your organization considers safe to perform. They essentially become a detailed map of your internal capabilities, and that map is exactly what an attacker wants to find. Their goal isn't necessarily to steal data right away, but to understand how to move through your systems and see what permissions are available to exploit. An MCP server is never just a simple pass-through for data. It is a concentration point. It acts as a single endpoint where dozens of tools, operations, and paths to sensitive information all live together in one place. If that server is compromised, an attacker doesn't just get access to one single capability. They get access to every single one of them. Every tool you have exposed through that server suddenly becomes a weapon that can be used against you. This is where supply chain risk starts to feel very real. MCP servers depend on external libraries, registries, and code that your team didn't write and doesn't control. If a malicious library finds its way into your build pipeline, or if a compromised package is published to a repository you use, your MCP server imports that threat directly into your infrastructure. It brings the compromise straight into your organization's data access layer without anyone realizing it happened. But there is a much more subtle attack vector that security researchers are starting to worry about, and it's called tool poisoning. The way it works is actually quite simple. An attacker doesn't even need to break into your MCP server directly. Instead, they can compromise any minor MCP tool that your server happens to depend on. It doesn't have to be a critical tool or something obviously dangerous. It could be a simple logging utility or a small script that formats text responses. Because it looks peripheral and harmless, the compromised tool sits inside your MCP server and remains completely invisible during a normal audit. Once it's inside, the compromised tool instructs the AI agent to do something completely unexpected. It might tell the agent to pull sensitive records, access systems it shouldn't touch, or invoke tools in a specific chain that creates a backdoor. The attack travels through the agent's own decision-making process, disguised as a legitimate response from a tool. The agent follows the instruction because it was told to trust that tool, and the audit trail will simply show that the agent made a choice. But that choice wasn't autonomous, it was coerced. Then we have to talk about prompt injection, which doesn't require compromising any code at all. Imagine your Dataverse contains thousands of customer support records with long text fields and detailed notes. An attacker can embed hidden instructions inside one of those records using language that is subtle and easy to miss. When the MCP server exposes that specific record to an AI agent, the agent sees the legitimate support ticket and the hidden command at the same time. That instruction might tell the agent to pull a customer's financial data or send private information to an external system. The agent follows the instruction because it is part of the context it is currently reasoning over. It has no way of knowing the command came from an adversary, so it treats the malicious text as part of the data it's supposed to process. When you look at the audit trail later, it looks like the agent just decided to do it. In reality, the agent was being manipulated by the very data it was trying to analyze. These attacks do not require massive sophistication or expensive zero-day exploits. They only require an understanding of how AI systems reason about trust and context. Attackers know that an MCP server will often expose tools without validating where they came from or checking what they are telling the agents to do. The need for strict governance becomes obvious here. MCP security is not a problem with the protocol itself, but a problem with the tools. It comes down to what you choose to expose through the server and how you maintain control over those choices. An overprivileged server that offers too many capabilities creates a blast radius that is almost impossible to contain. One compromised tool can enable a dozen different attacks, and one poisoned record can change how your agents behave. This is why the shift in how we think about security has become so urgent. You cannot just connect Dataverse to an MCP server and assume the security will handle itself. You have to think critically about which tools are safe to expose and understand exactly what damage they could cause if they were misused. You have to validate the integrity of every piece of code you're running. Most importantly, you have to implement controls that limit what a tool can do, even if the agent using it has been manipulated. This is exactly why moving to an MCP architecture requires a high level of security maturity. The architecture shift from point to hub and spoke. The old way of building architecture was defined by sprawl. It was unsystematic and mostly happened by accident. You had a Salesforce instance, a Dataverse environment, a data warehouse, and maybe a few legacy applications. To make them work together, you built custom connectors. You probably had dozens or even hundreds of them. Each one was a point-to-point connection where System A talked to System B through a bridge built for that one specific conversation. The problem is that this kind of complexity isn't linear. It compounds. If you have 3 systems and 3 apps using them, you have 9 integration points to manage. But if you move to 10 systems and 10 apps, you suddenly have 100 points of failure. The number of problems grows exponentially with every new piece of software you add. Eventually, the network becomes so tangled that nobody in the company fully understands how it works. When something inevitably breaks, you have no idea which downstream teams are going to be affected. The new architecture model inverts this entire mess. Instead of those messy point-to-point lines, you build a hub-and-spoke system. You create one MCP server for each business domain, such as a server for sales, one for support, and another for finance. Each server exposes only the tools and data relevant to that specific part of the business. Now, your AI clients like Claude or GitHub Copilot don't connect to the underlying databases anymore. They connect to the MCP servers, discover what is available there, and perform their work through that single interface. This pattern isn't actually new, and it has been proven to work in almost every other layer of infrastructure. API gateways work this way, service meshes work this way, and even message brokers follow this logic. You create one central point that knows how to talk to a family of related systems. The clients talk to that center, and the center handles the headache of connecting to everything else. The architectural benefit here is huge. When Salesforce decides to change its API, you only have to update the Sales MCP server one time. Every client using that server will automatically work with the new version. You don't have to go back and rewrite 50 different integrations because you only have one to worry about. The same principle applies to your data warehouse, your legacy systems, and everything else in your stack. One server per domain handles many different clients. But there is a governance benefit here that is even more important, though it's often less obvious to teams at first. When you rely on point-to-point integrations, your governance is scattered all over the place. Security policies live in 10 different locations. One connector might use strong encryption while another one doesn't. One team might log their data to the cloud while another team saves it to a local file share. You end up with a mix of OAuth and API keys, and your audit trails are fragmented across a dozen systems. You don't have a real policy, you have policy chaos. A hub-and-spoke model changes the game because it gives you one place to enforce the rules. One MCP server for a domain means you have one set of rate limits and one clean audit trail. It gives you a single place to manage approval workflows, data classification, and access controls. When you need to update a security policy, you change it in one spot, and every client using that server sees the change immediately. This is the architectural shift that actually matters for the long term. You are moving away from seeing integration as a point problem, where you solve each connection one by one. Instead, you are treating integration as a platform problem. You are building a layer that handles the complexity once, so that your users don't have to deal with it over and over again. The implication here is subtle, but it completely changes what your team is actually building every day. In a point-to-point world, you are just building connectors. You are solving small, specific problems like getting System A to talk to System B. That mindset focuses on speed and getting the immediate task done. It doesn't care about sustainability or governance because those things aren't visible when you're just looking at one single bridge. With a hub-and-spoke model, you are building a platform. You are designing a surface and thinking about how a domain should be governed. You are forced to think about how multiple different clients will use these tools in the future. You start planning for how to absorb changes before they even happen. This mindset is what allows you to scale as demand grows. The organizations that are actually going to succeed with MCP are the ones that make this mental shift. They stop looking at integration as a series of connector problems and start seeing it as a platform challenge. Dataverse as context, not just storage. Most organizations are stuck in an old mental model where they view Dataverse as nothing more than a database. They see it as a repository, a place to store records, or a bucket where you dump customer data and log transactions. In this traditional view, you persist everything the company needs to remember. And then, when you need that information, you query it. It is a simple cycle of storage and retrieval, which is exactly how databases have worked for decades. But that model is ending. Dataverse isn't becoming less of a database, but it is certainly becoming something much more significant. It is transforming into a context layer, serving as the semantic foundation for how your organization's AI actually understands itself. This isn't just about where the data lives anymore, but rather how that data carries meaning and what specific connections exist between different entities. It defines the business logic, explains why certain fields exist, and outlines the constraints that govern how they are used. Think about the difference between a human and a machine looking at a table. A database optimized for people doesn't really care about deep descriptions because the field might be named actable, and you already know what that is. You've seen it 1,000 times, you understand it intuitively, and whether or not there is a tooltip in the interface doesn't change much. The human sees the data within a visual context, like a form or a dashboard, and that surrounding interface tells them exactly what they are looking at. An AI system doesn't have the luxury of a contextual interface because it only sees the schema, the field names, and the data types. If a field is labeled ACTT-BAL, the AI doesn't automatically know if that represents a customer's personal balance or an internal clearing account used for back-end processing. It has no idea if that field should be visible to the support team or if changing that number triggers a massive chain of business processes. The AI understands the technical definition, but it is completely blind to the actual business meaning. The Model Context Protocol changes this dynamic entirely. Because MCP exposes your schema dynamically, the quality of your metadata becomes immediately visible and carries massive consequences for your results. An AI system can now ask what a specific field represents, and the server responds with the description you wrote. If that description is cryptic or lazy, the AI is going to struggle, but if it's clear and focused on business logic, the AI finally understands. This is the fundamental shift you have to make. You aren't just storing data points anymore. You are curating semantic meaning for a non-human intelligence. You are encoding the way your organization thinks into a structure that an AI can actually reason over. Field descriptions are suddenly the most important part of your setup, not because users need them, but because the AI requires them to function. These descriptions need to be written for how a large language model processes language, which means moving away from technical jargon and database shorthand. You need to use clear, concise business language that explains what a field represents and why it exists in the first place. When an LLM LLM reads account balance as of last reconciliation used for reporting and fraud detection. It understands the purpose, but when it reads active bal, it understands nothing. Relationship definitions have to change as well. In a traditional database, relationships are just structural links enforced by foreign keys that stay invisible to the average user. In an AI context, those relationships are semantic pathways that help the AI understand how different parts of your business connect. If you explicitly define that accounts relate to opportunities and those relate to activities, the AI can traverse those links to gather its own context. It begins to understand your business structure implicitly because you took the time to make those relationships explicit. The same logic applies to your business rules, validation steps, and workflow triggers. Usually this logic is buried in code, hidden in plugins, or tucked away inside Power Automate flows where the AI can't see it. If you expose which business rules apply to which entities, the AI starts to understand the constraints of your organization. It learns that certain operations require approval or that changing one field might cause a cascade of effects. It begins to operate within your organizational boundaries because you made those structures visible through metadata. This changes everything about how we handle data governance. For years, you've been optimizing your data so humans can read it on forms or so developers can write fast queries. Continuing that same approach under MCP is a major mistake because you now need to optimize for an AI's ability to reason. Your data structures must support autonomous discovery, and your descriptions must be precise enough that an AI can make confident choices. This is the deeper requirement that most organizations miss, and it isn't a technical hurdle, it's an organizational one. Data modeling for AI, the hidden cost of poor schema. Large language models are incredibly sensitive to how you package information, though that isn't always obvious until you watch a system fail. If you give an AI a Dataverse table with 50 fields but no descriptions, you are essentially handing it a puzzle with missing pieces. Imagine field names like FLD001 or cryptic codes from a legacy system built in 1997 that nobody on your current team even remembers. Without context or explained relationships, the AI just sees a flat list of attributes with no way to know what is sensitive or what actually matters. It might have the permissions to access the data, but it doesn't understand the business context or the constraints governing that information. In that scenario, the AI is going to do one of two things. It will either make a lot of mistakes or it will ask you for permission every 5 seconds. The system becomes brittle, requiring explicit instructions for every tiny operation because it lacks the foundation to make its own decisions. You end up with an AI that can technically reach your data but practically has no idea how to use it effectively. Now compare that to an AI working with a table where every field has a clear business-readable description. When relationships are defined and sensitive fields are clearly marked, the AI sees a map of your business rather than just a list of numbers. It knows which fields are safe to expose, it understands the implications of its actions, and it can chain complex operations together. The difference isn't the data itself, but rather how that data is presented to the model. This is a context engineering problem. You can have the highest data quality in the world with perfect values in every single row, but if your schema is opaque, the AI is useless. Organizations that jump into MCP without doing this foundational work usually end up disappointed very quickly. They connect their tools, expect instant efficiency, and then get frustrated when the AI makes mistakes or constantly asks for clarification. They usually blame the tool or the connector, but the real culprit is almost always the underlying schema. The real cost here isn't technical. It's the weight of 20 years of data modeling choices made without ever considering an AI consumer. Most of your Dataverse implementation was likely built for humans who use forms, reports, and dashboards to find their way around. A person sees a label that says account balance, and they know exactly what to do, regardless of what the actual database field is named. But the AI doesn't see your beautiful UI, it only sees your metadata. If that metadata is poor, the AI's entire understanding of your business will be poor as well. The best practice here is simple to understand, but requires a lot of discipline to actually execute. You have to start writing metadata specifically for an LLM to read, rather than for a developer who already knows the system. Field descriptions should be complete, such as total balance of all accounts held by this customer, updated nightly for credit decisions, instead of just balance. You have to stop using abbreviations that only made sense 30 years ago and start using the language of your business. This logic applies to every single part of your schema, from field names to business rules. You have to be explicit because an AI cannot infer meaning the way a human does. When a person sees a field called modified by, they automatically know it refers to the last user who touched the record. An AI doesn't just know that, it only knows what you have explicitly told it through your metadata. The organizations that actually succeed with MCP are the ones that do this heavy lifting before they ever turn on a connector. They audit their schema, rewrite their descriptions, and define relationships that might have been technically functional, but were semantically confusing. They document their constraints and mark their sensitive data so that when they finally deploy MCP, the difference is night and day. The AI operates with a level of confidence that requires far less human oversight. The hidden cost of AI adoption is the work that happens before the tools even arrive. It's the metadata cleanup, the schema reviews, and the documentation of business rules that everyone wants to skip. This isn't just infrastructure work, it is the architectural foundation of the future, and it's the one step that organizations consistently underestimate. That is where the real work lives. The organizational impact, new roles, new skills. Moving to MCP isn't just a technical swap that keeps your org chart the same. It is a total role transformation. The work your integration engineers do is changing, but it isn't disappearing. That is a distinction you need to understand clearly. You aren't actually cutting developers. Sometimes leadership sees MCP slashing implementation times from 8 weeks down to 2 days and assumes the headcount should shrink too. But that is looking at it backwards. What is really happening is that your developers are moving away from writing glue code and starting to design platforms. Before MCP arrived, the job of an integration engineer was very straightforward. You had a problem where System A wouldn't talk to System B, and you were the person who forced them to communicate. You spent your days writing REST wrappers, handling authentication, and translating API contracts into something another system could actually read. You wrote the error handling, tested the deployment, and then you maintained that specific connection for the next 5 years. You stayed busy because there was always a new system to connect, and every time an underlying system changed, you had to go back in and fix the bridge. That work still exists in the world, but here is the problem. It isn't the bottleneck anymore. The bottleneck has shifted. Now the real challenge is designing which tools should be available through your MCP servers. The struggle isn't the technical connection itself, but rather designing the semantic surface. You have to understand which business capabilities your organization actually exposes through Dataverse and how those pieces relate to each other. You need to figure out who gets access, what constraints govern the operations, and how to make that surface discoverable for AI. Designing that interface so it supports AI-driven workflows is a different skill entirely. A new role is emerging called the MCP server owner. This person owns the tools, the scope, and the governance for a specific domain. They understand what an MCP server should expose because they actually understand the business side of the house. They work closely with the teams owning the underlying systems to understand the data models and security constraints. Then, they design tool interfaces that make those rules visible to AI agents. They are the ones deciding which operations are safe to automate and which ones still need a human to click approve. This isn't just API design, it is tool design and capability modeling. It is about predicting how an AI will discover a resource and then building the surface to match that behavior. The people who excel here understand both technical limits and business intent. They aren't just developers and they aren't just business analysts. They are architects who act as a bridge between the two worlds. The skills for this are still being defined. There is no degree for becoming an MCP server owner yet, but the pattern is getting easier to see. You need people who know your domain deeply and understand how Dataverse functions. You need writers who can describe complex business logic clearly so an autonomous agent can actually use it. Most importantly, you need people who understand governance well enough to draw the line between what is safe and what is dangerous. Your current developers can absolutely learn this. It isn't a brand new skill set, but rather an evolution of what they already know. If someone has spent 5 years building custom connectors, they already understand integration complexity and they know exactly what breaks. And if you give that person training on tool design and agent behavior, they will become incredible at building MCP servers. But you have to recognize the capacity shift. You aren't moving from writing integrations to doing nothing. You are moving from writing integrations to designing tool platforms. The work is different, the output is different, and the impact is much higher. One engineer can now unblock 50 different AI use cases instead of solving one single point-to-point connection. That isn't less work, that is leverage. The organizational reality is that you will need fewer people doing repetitive manual labor and more people doing high-level architecture. You need thinkers who can be strategic about which capabilities the company should expose and how to govern them. You need people who realize that tool design is really about making constraints visible to autonomous systems. This is where the shift stops being technical and starts being organizational. The business case, why executives should care about MCP. This is where we move away from the technical details and talk about the bottom line. This is why your CFO, your CEO, and your board should view MCP differently than a standard infrastructure decision. Technology leaders care about architecture because that is their job. They worry about protocols, schemas, and whether the system is designed to scale. Those are infrastructure concerns. But executives care about something else entirely. They care about velocity, competitive positioning, and what the organization can actually get done this quarter. The technical gap between custom connectors and MCP is massive. But for an executive, the difference is much simpler. It is speed. Imagine you have a business problem that AI could solve. You want to pull customer data, compare it to operations data, and have a model generate recommendations. Your team could build this, and it would save time and improve every decision you make. It is clearly worth doing. But how long does it take to actually launch? If you use custom connectors, you are looking at a full-scale project that takes 8 weeks minimum. You have to scope it, build the connector, validate the data, and then monitor the deployment. While you are stuck in that cycle, your competitors who already have MCP infrastructure have already built their automation. They are already learning from it and gaining an advantage while you are still stuck in the design phase. Then another problem pops up. You see another chance to use AI, but it requires a different system. That is another 8 weeks of waiting and another project cycle. You are looking at another quarter of standing still. The company that can say, we will have that running in 2 days, has a massive strategic advantage over the company that says that is a 6-month project. That isn't a technical win. That is a business win. It is the difference between being reactive and being nimble. It is how you dominate a market instead of just surviving in it. This is the core argument for velocity. When you use MCP, new AI use cases don't start massive infrastructure projects. They just trigger configuration tasks. The tools are already there, Dataverse is already exposed, and the security model is already set. You aren't building from scratch anymore. You are consuming what you already have. You aren't designing for one specific use case, but using existing capabilities to solve new problems. That changes your timeline and expands what your team can attempt in a single month. This is also the shift from AI as a project to AI as a capability. Right now, most companies treat AI like a one-off project. You find an opening, you assign a team, you fund it, and you get a result. When the project ends, the team moves on. This works, but it is serial. You can only do one thing at a time, and you are limited by how many projects your managers can handle at once. But the best organizations are making a change. They are building AI as a core capability that the company just does. It becomes like analytics or reporting. AI-driven automation isn't a special event. It is just how you operate every day. This shift only happens when the infrastructure removes the friction. When adding AI to a workflow doesn't require an 8-week integration, anyone with a good idea can try it. When the barrier to entry is low enough that you can afford to fail, AI stops being something you plan for and starts being something that just happens. For an executive, that is the pitch. Your speed in deploying AI goes up, your competitive position gets stronger, and your organization learns to adapt faster. That is the business case. But there is a catch. You can't just flip a switch and expect all of this to work instantly. The governance-first approach, why you can't just flip a switch. Most organizations stumble right at the starting line. They see the business case. They understand why velocity matters. They decide to deploy MCP, but then they treat it like a standard IT project. They install the local proxy, configure the connection to their Dataverse tenant, and point their AI tools at the data. They announce the big rollout to the company, and then they're completely shocked when the security teams step in to shut it down. That pushback isn't just red tape. It's the sound of the organization realizing that flipping the switch on MCP without a plan creates a massive backdoor. You've essentially built a way to sidestep every security control you've spent the last decade putting in place. Adopting MCP is not a technical migration, and that's the fundamental misunderstanding most leaders have. You aren't just swapping one protocol for another or upgrading your server infrastructure. You are actually restructuring how your entire organization exposes its capabilities to autonomous systems. This is a governance problem, not a technical one. The coding and configuration might take up 20% of your time, but the governance work is the other 80%. The temptation is to just expose everything in Dataverse through MCP and hope for the best. You have a platform full of data and an MCP connector ready to go, so you figure you'll just let the AI sort out what's useful. That approach sounds efficient on paper, but in reality, it's incredibly dangerous. It's like handing an unsupervised AI the keys to every filing cabinet and office door in the building and trusting it to behave. The AI might not have bad intentions, but intentions won't stop a disaster when the boundaries are invisible. A governance-first approach means something very specific. Before you ever build an MCP server, you have to decide exactly what it should be allowed to see. You aren't asking what is technically possible, but what is strategically appropriate for an AI to handle. You have to ask which business capabilities are safe for an autonomous system to trigger without a human in the loop. You need to know which data is routine and which is sensitive, and you must define the business rules that the AI has to follow. This requires absolute clarity on ownership. You need to know who owns the MCP server from a business perspective, not just who maintains the code. Someone has to be accountable for what that server exposes to the world. That person decides when to add a new tool, reviews every change, and monitors how the system is being used. These aren't just academic questions for a meeting, they are operational necessities for the system to function. Without a clear owner, your governance model will eventually fail. You also need to be ruthless about the scope of your data. The MCP server shouldn't have access to everything in Dataverse. It should only see a specific subset of information. You have to define which tables and fields are open and whether the AI can create, read, update, or delete records. There are always files that should stay off limits, like customer bank details, HR records, or sensitive contract negotiations. That scope has to be written in stone and enforced at the server level, so there's no room for error. Then you have to look at your approval workflows. You need to decide which actions require a human to sign off before the AI can execute them. This might include creating new records, exporting data in bulk, or changing any business-critical information. These gates have to be designed before you deploy the system, because trying to retrofit them after a mistake happens is a losing game. You have to enforce these rules at the tool level rather than just hoping they work downstream. Without this structure, MCP just becomes a new way to build shadow IT. Teams will start spinning up their own servers without any oversight, and they will inevitably expose more data than they should. They won't log the activity properly, and they'll create approval steps that nobody actually follows. This leads to invisible integration, where autonomous systems are running with permissions that nobody in the company fully understands. When data starts flowing in ways the governance team can't see, you're in a worse position than the old model. The maturity requirement here is very real. If you want to move to MCP, you need strong data governance already running in your organization. You need clear owners for every data domain and a solid understanding of what information is sensitive. You must have the discipline to audit your systems and the structure to enforce your own policies. If you're already struggling to manage your data or your audit trails are a mess, adding MCP will only make those problems explode. This is the hard truth that sends most organizations into a tailspin. They deploy the technology first because the business case looks great, and they tell themselves they'll handle the governance later. By the time they get around to it, they've already created a massive mess and exposed things that should have stayed private. The blast radius is always larger than they expected. The organizations that actually succeed are the ones that plan their governance before they write a single line of code. They define the boundaries, build those rules into the servers, and monitor the results constantly. That timeline takes longer to get started, but the final outcome is actually sustainable. This is where the shift from a cool demo to real work actually happens. The common mistakes, what organizations get wrong. Pattern recognition is a powerful tool when you're looking at how companies fail. When you study the organizations that have tried to move to MCP, you see the same mistakes happening over and over again. These failures don't happen because the people are bad at their jobs, but because their mental models are incomplete. They don't quite grasp what MCP is meant to do, and that confusion leads to very predictable disasters. The biggest mistake is trying to build one giant monolithic MCP server that handles everything. Leaders think they're being efficient by putting every table, every tool, and every business capability into a single place. They assume maintaining one server is easier than maintaining 10, but the reality is the exact opposite. The server that tries to do everything becomes impossible to manage almost immediately. You can't set clear boundaries, and an AI agent looking at 10,000 different tools will never be able to figure out what's actually relevant. It just turns into noise, and that single server becomes a massive point of failure where one small mistake can take down your entire operation. The second mistake is getting your timeline backwards. Organizations decide they'll deploy the technology now and figure out the rules of the road later on. But governance later almost always turns into governance never, or at least not until something breaks. Teams start building servers without any review process, permissions get set incorrectly, and people skip the approval steps because they're a hassle. By the time the governance team realizes what's going on, the mess is so deep, it takes months of work just to untangle it. The third mistake is launching MCP without cleaning up your Dataverse metadata first. If you expose a table that uses cryptic internal codes and has no descriptions, the AI won't have any idea what it's looking at. It will either stop to ask for permission every 5 minutes, or it will start making dangerous assumptions about your data. Sometimes the AI will just refuse to use the table at all because it can't reason through the logic. In those cases, people usually blame the connector, but the real problem was the messy data they fed into it. The fourth mistake is thinking that MCP is a total replacement for REST APIs. It isn't, and REST APIs are not going anywhere anytime soon. They are still the best choice for things like moving huge amounts of data, scheduled background tasks, or high-speed communication between servers. MCP is built for something else entirely, which is discovery-driven access for autonomous systems that need to understand intent. If you try to force everything through MCP, your system will end up slower and more complicated than the one you replaced. You have to use the right tool for the right job. The fifth mistake is moving too fast without setting up proper audit trails. MCP makes it incredibly easy to access data, but easy access without any visibility is a recipe for a security nightmare. You need to log everything, including what was requested, who asked for it, and exactly what data was sent back. Without those detailed records, you won't be able to investigate when something inevitably goes wrong. You won't be able to prove what happened, and you won't be able to fix the root cause. There is a clear pattern underneath all of these common failures. The organizations that win with MCP are the ones that do the boring work before they start the exciting work. They design the governance, define the scope, and clean up their data before they ever go live. The teams that stumble are the ones who skip the planning phase and hope that fast execution will solve their problems. It never does. The cost of these mistakes isn't always obvious on day one. A poorly designed server might work perfectly fine for a few weeks, but eventually it becomes a massive liability that's too hard to maintain. By the time you have to replace it, you've wasted months of time and lost the trust of your stakeholders. This is the point where strategic thinking becomes much more valuable than the technical implementation itself. The maturity model, from custom integration to MCP ready. You need to know where you stand on the MCP journey because not every organization starts from the same place, and honestly, not everyone needs to reach the same finish line. Having a clear framework just helps you put your resources where they actually matter. Think of maturity as a landscape you move through rather than a ladder you climb in neat robotic steps. Every stage has its own personality, its own set of headaches, and its own specific requirements. Level 0 is the current reality for most companies, and it usually looks like custom connectors scattered everywhere with no central plan. Integration decisions happen locally because one team needs Salesforce talking to Power Platform, while another team is busy wiring a data warehouse into an analytics tool. Then a third team builds something from scratch just because they couldn't find a pre-made connector that did exactly what they wanted. You end up with dozens or even hundreds of these integrations, but they aren't coordinated or governed, so they just sit there. Integration eventually becomes a massive bottleneck because there is no standard way to add new connections, meaning every new system requires a fresh round of custom work. Level 1 is where you finally take an inventory of the mess. You actually know which connectors you own, and you've started thinking about how to consolidate them into something manageable. Maybe you've picked a platform like Azure Logic Apps or a third-party iPaaS to host everything, but you're still mostly building custom connectors. MCP isn't even in your vocabulary yet, and you haven't deployed a single server, but the organizational structure is starting to take shape. You have an integration team and a catalog of what exists, which means you've at least admitted the problem is real. Level 2 is the experimentation phase where you decide to give MCP a shot. You've deployed your first servers, but you aren't trusting them with business-critical workloads quite yet. Instead, you're testing with support data or low-risk analytics to learn how to design these servers and figure out the governance. You will definitely run into problems like metadata errors, design flaws, or permission boundaries that don't feel right, but that is exactly why you're doing this. You are learning in a controlled environment while your governance framework starts to emerge in draft form. Most of your portfolio is still custom connectors, but for the first time, you can actually see a future where that changes. Level 3 is where the shift becomes undeniable. Your core business domains, sales, support, finance, and operations, are now exposed through production-grade MCP servers. Real AI automation is running against these workloads, and your governance framework is finally being enforced with audit trails flowing directly to your CM. You have clear ownership and approval workflows for sensitive tasks, making MCP the primary way AI accesses your data. Custom connectors are moving into maintenance mode, and while they aren't retired yet, they aren't growing either. New AI use cases are built on MCP, and the velocity change is obvious because projects that used to take 8 weeks now only take 2. Level 4 is the final destination where MCP becomes the default for every new AI use case. When a business problem comes in, nobody asks if they can build a custom connector. They ask if an MCP server already exposes the data they need. Custom connectors are officially deprecated and only exist for legacy systems that haven't been wrapped in an MCP server yet. They aren't being maintained beyond basic security patches because integration is no longer a bottleneck. It's a platform capability, allowing the organization to build new automations at the speed of business decisions rather than the speed of infrastructure projects. The timeline here is a reality check because most organizations won't move through this progression in a few months. Moving from level 0 to level 3 typically takes 12 to 24 months, and that isn't because the technology is slow. It takes time because governance restructuring is hard, metadata needs cleaning, and teams have to learn entirely new skills. Organizational change is just naturally slower than infrastructure change. This timeline matters because it sets your expectations. You aren't going to deploy MCP and hit level 3 by next quarter. You're going to be at level 2, finding gaps and learning from mistakes. That isn't a failure, it's just the process. Organizations that try to skip the governance work to move faster are usually the ones that end up with a bigger mess. The real question isn't which level you should aim for, but which level actually makes sense for your specific business drivers. Dataverse roadmap, what's coming? Where this technology is heading matters for the decisions you need to make right now. If you're looking at adopting MCP, you need to know what is being prioritized and what is still just a preview feature. The roadmap tells you if the gaps you see today are being fixed or if you'll be stuck with workarounds forever. Microsoft is treating Dataverse MCP as a first-class platform capability, which is a big deal. Not every Microsoft investment gets this kind of attention, as some features are announced and then slowly fade into the background. The signal from the 2026 release plans shows that Dataverse MCP is getting consistent resources. The Power Platform Wave 1 release specifically mentions improving server quality with updated tools, which isn't just a minor add-on. It is foundational infrastructure work, and it proves that Microsoft is preparing for massive scale. These planned updates are important because they solve the exact problems people are dealing with today. Remote MCP servers are finally on the roadmap, which changes everything. Right now, you have to run a local proxy on your machine or network to make Dataverse MCP work. Remote servers mean the code can run anywhere, whether that's in Azure, a container, or as a managed service. This removes the burden of managing proxy infrastructure yourself and turns MCP into something Microsoft maintains for you. Table-level CRUD operations are also on the way to give you better control. Currently, the MCP server is somewhat limited in what it exposes, but as create, update, and delete functions expand, you get much finer control over what AI agents can do. Right now, it's easy to show an agent how to read data, but writing data is much more difficult. As these CRUD operations grow, the range of use cases for MCP expands, making things like autonomous record creation and bulk updates actually viable. We are also seeing better admin controls on the horizon to fix current governance gaps. Right now, you can block an entire MCP server, but you can't get surgical and block individual tools within it. Microsoft is moving toward more precise controls and richer audit trails, which is a direct response to the feedback they're getting from early adopters. The biggest governance milestone to watch is advanced connector policies moving from preview to general availability. These policies are how Microsoft plans to fix the DLP gap, because classic policies simply don't see MCP servers yet. As of early 2026, these are still in preview, so you can't fully rely on them for production. When they finally hit general availability, you'll be able to enforce DLP policies with real regulatory teeth and actually prove compliance. Identity is the other piece of the puzzle that changes the game. Intra-agent identities are coming, and they will finally separate what a human did from what an agent decided to do. Until these reach general availability, organizations are stuck with ambiguous audit trails that make accountability difficult. Once they are production ready, that gap closes and actions are correctly attributed to the agent itself. This isn't just a small fix, it's a fundamental shift in how we trust autonomous systems. Performance is also getting a major overhaul because high-volume agents need better engineering than simple experiments. We're seeing work on caching strategies, schema efficiency, connection pooling, and rate limiting. This is the same infrastructure work that made REST APIs reliable at scale years ago. The underlying message here is very consistent. Microsoft sees MCP as the future architecture for how AI interacts with enterprise data. It isn't just one option among many, it's the path forward. They are investing in the infrastructure and closing the gaps because they are preparing for a shift they believe is inevitable. The action plan, starting your MCP journey. You need a starting point, not a vision, not a transformation roadmap, a starting point. Monday morning, what actually happens? Here is the realistic timeline for organizations moving from where they are now to operating MCP at scale. Month 1, audit and prioritize. Start by understanding what you actually have. Not theoretically, concretely. Run an inventory of every custom connector, every integration service, and every bespoke middleware component your organization maintains. This isn't an exercise in documentation, it's an exercise in honesty. What is actually running, what is in production, what is half maintained and barely understood. You need to identify what is so critical that losing it would break the business and contrast that against what is so peripheral that you are not even sure what it does anymore. Map each integration against a simple criterion. Is this a candidate for MCP? Some integrations are so high throughput or so latency sensitive that they will never move to MCP, so you should leave those alone. Other integrations exist only because point-to-point was the only option available 5 years ago. Those are your candidates. They do not need the performance characteristics of REST. They need the governance and discoverability benefits of MCP. Separate the two groups. You are not retiring everything. You are identifying what could benefit from the shift. Month 1 to 2. Metadata cleanup. This is where most organizations delay or skip work. Don't. Before you even think about deploying MCP, your Dataverse metadata must be written for AI to read. Go through the tables you have identified as MCP candidates and ensure every field has a description written in plain English. Explain what it represents, explain why it exists. These are not technical definitions, they are business meanings. Instead of phone or contact PH, you write customer's primary contact phone number used for support outreach and fraud verification. This work feels tedious because it is. It is also non-negotiable. You are not just cleaning up documentation. You are building the foundation for autonomous systems to reason over your data effectively. Spend the time, get it right. The weeks you invest here prevent months of agent behavior problems downstream. Month 2, design your first server. Pick a non-critical domain. Support data is often a good choice. Analytics is another. You want something where mistakes have a limited blast radius. Something where you can experiment and learn without regulatory pressure. Design what that MCP server should expose, not everything in that domain. A thoughtful subset. Which capabilities should AI agents invoke autonomously? Which operations require human approval? Which data is sensitive enough that access should be restricted? Write it down. Don't build yet. Design first. Month 2 to 3. Governance framework. Before the server goes live, you need the guardrails in place. Define who owns the server, who approves changes, what approval workflows apply to which operations. You need to determine what audit logging is required and how you will detect misuse. If something goes wrong, you need a plan for how to respond. Write actual policies, not aspirational guidelines. Enforceable policies that your teams will implement. This is the governance infrastructure that keeps MCP from becoming chaos. Month 3 to 4, pilot deployment. Deploy the MCP server to a pilot group. One business use case, one team, one AI tool. Measure what changes. How long did it take to build the automation compared to if you had used custom connectors? What issues emerged? What worked better than expected? You need to see which governance controls needed adjustment. This isn't production at scale, it's controlled learning. Month 4 plus, deliberate expansion. Once the pilot succeeds, expand gradually. Add another domain, build another MCP server, retire the custom connectors that MCP now handles. This isn't a race, it's a structured migration. Each new domain teaches you something. Each new server improves your pattern. Each retired connector reduces your maintenance burden. The timeline matters less than the sequence. Audit, then improve metadata, then design, then govern, then deploy, then expand. Skip steps and you create problems. Rush and you build on weak foundations. The structural shift. What's actually changing? You can understand MCP technically and miss what is actually changing. The protocol is JSON RPC. The architecture is hub and spoke. The tools are discoverable. The governance is centralized. You can comprehend all of that and still not understand the fundamental shift happening underneath. The shift isn't technical, it's philosophical. For 20 years, integration teams asked a specific question. How do I connect this system to that system? That's the question that defined the work. You have Salesforce over here, you have a data warehouse over there. How do you make them talk? You build a bridge. You write code that understands the Salesforce API, understands the data warehouse schema, translates between them, and handles the errors. That's the integration problem. That's what consumed engineering effort and mental cycles for decades. That question is still valid. You still need to connect systems, but it's no longer the organizing question. The organizing question is shifting. Now the question is, what capabilities should this system expose? That is a different question entirely. It is not how do I connect. It is what do I want others to do with this system? Not what can I technically make possible, but what should be possible? Not how do I write the code, but what does the surface look like? This isn't semantic wordplay. This is a structural shift in how you think about the problem. When you ask how do I connect, you are thinking about point to point. You are solving a specific problem. You are writing code. You are building the bridge. The code solves that particular problem and then you are done until the next problem arrives. This mindset optimizes for the speed of individual solutions. It focuses on velocity for the current task and getting the connector built. But when you ask what should this system expose, you are thinking about platforms. You are designing surfaces. You are thinking about all the potential consumers and what constraints should be visible. You are deciding what should be safe and what shouldn't. You are thinking about governance and discoverability. This mindset optimizes for sustainability. It focuses on reusability and letting the system evolve without breaking everything downstream. These questions produce different results. The first question produces a collection of custom connectors. Each one solves one problem. Each one embeds the thinking of the person who built it. Each one handles errors in its own way. Each one implements security differently. Together they form a patchwork. It works, but it is not cohesive. It is not governed. It is not sustainable at scale. The second question produces platforms, design surfaces, explicit boundaries, intentional choices about what is available and what isn't, consistent governance. It requires more upfront thinking, but the result scales. The result evolves. The result can be governed. MCP isn't forcing this shift, but it is enabling it. By making it possible to expose tools through a standard protocol that AI can discover, MCP removes the constraint that made point-to-point feel necessary. Before, you needed custom code for each connection because every consumer was different and every consumer had different requirements. But with MCP and AI automation, you can have many consumers accessing the same tools through a standard interface. That makes platform thinking practical. The organizations succeeding with MCP are the ones making this mental shift consciously. They are not deploying MCP as a replacement for custom connectors. They are deploying MCP as a different way of thinking about integration. They are asking different questions. They are designing surfaces instead of building bridges. This is also why you cannot just bolt MCP onto your existing integration infrastructure and expect success. The technical integration is easy. Plug in the connector, done. But the thinking shift is hard. It requires you to look at your systems differently. You have to ask yourself what capabilities you want to expose rather than just what you need to connect. You have to think about governance and boundaries explicitly rather than implicitly. You have to design for discoverability rather than just for functionality. The organizations that treat MCP as a technical implementation fail quietly. They deploy it, they get some value, but they don't unlock the velocity gains because they haven't made the conceptual shift. The organizations that treat it as a thinking shift, as a fundamental change in how integration should work, those are the ones that get the disproportionate returns. It's not about the protocol, it's about the model, the future. What MCP means for enterprise integration. The path forward is visible. It isn't a certainty, because nothing ever is, but the direction matters much more than the speed right now. Custom integration as we know it is ending. This won't happen in 6 months, and it might not even happen in 2 years, but the model that organized how companies connect systems for 2 decades is finishing. The real question isn't whether this shift happens. It's how quickly it moves and who gets left behind in the process. Within 3 to 5 years, MCP will be the default way that AI accesses your enterprise data. It won't be the exception or some innovative side project. It will be the default infrastructure layer that every new AI use case sits on top of. Organizations will stop thinking about integration as a series of point-to-point connections and start seeing it as a capability platform. The companies that move early will finish their consolidation, while the ones that delayed will still be stuck, managing a messy hybrid of custom connectors and REST APIs. This isn't a prophecy, it's just tracking the inevitable. The economic forces driving this change are structural, which means you simply cannot maintain hundreds of custom connectors under the cost structure that AI creates. You can't stay competitive if every new AI project requires 8 weeks of integration work while your competitor deploys in days. Governing AI-driven data access becomes impossible when that access is scattered across point-to-point connections that nobody fully understands. The old model breaks under scale, and organizations will migrate away because they have to, not because they want to. Competitive advantage goes to the teams that make this shift early and on purpose. These organizations aren't drowning in integration debt because they're busy building platform capabilities instead. They measure the velocity of new AI automations in weeks rather than months. They deploy insights at a pace their rivals can't match because their infrastructure actually supports that scale. For a few years, this creates a massive structural advantage. And while the laggards might catch up eventually, the gap will be wide by then. So what happens to the companies that don't move? They won't disappear, but they will become severely constrained by their own lack of capacity. They'll spend their time maintaining old infrastructure and building custom connectors for every new problem that pops up. While they wait months for a single automation project to finish, their competitors will be experimenting and learning every single day. That rate of experimentation compounds into a massive disadvantage over time. The slower organization falls behind because they're running the same race on a treadmill while everyone else moves forward. This shift is inevitable because the economic equation has tipped. It isn't about MCP being perfect or custom integration being bad. It's about the fact that the cost structure has changed. Organizations in competitive markets have to move or they will lose. That's the mechanism at work here. We also have to look at how vendors are converging. Anthropic didn't create MCP because they had a problem with REST APIs. They built it because they saw a future where AI agents are autonomous and need a standardized way to talk to enterprise systems. OpenAI, Google, Microsoft, and AWS all see the same thing. The entire AI industry is moving toward MCP as the integration layer for the future. That consensus makes any individual resistance irrelevant because the train is already moving. You can be on it or you can be run over by it. The leaders who understand this are making different decisions right now. They aren't debating whether to move to MCP, but are instead busy planning the actual migration. They're training their teams and accepting that this is necessary infrastructure work rather than optional innovation. That mindset changes everything from how they allocate resources to who they hire and where they invest. Dataverse MCP isn't the end of integration. It's the end of custom integration being the default way we solve problems. That is the distinction that matters. For the last 20 years, integration meant writing code and building wrappers for specific problems. That model served its purpose when change was slow and scale was limited, but that era is over. You're moving from static endpoints to intent-driven context discovery. You're moving from building bridges to designing platforms. You're moving from solving one-off problems to building sustainable infrastructure. This shift requires 3 specific things from you. First, you need to audit your custom connectors to see which ones are actually candidates for MCP. Second, you must improve your Dataverse metadata right now, even before you deploy anything. Write descriptions that an AI can actually reason over, so your data structure is intelligible to an autonomous system. Third, design your first MCP server with a deliberate plan. Start small, learn the lessons, and then scale up. Don't just deploy and hope that governance follows later. You have to build governance into the deployment from day one. The future of enterprise integration is intent-driven, governed, and standardized. Dataverse MCP is the tool that gets you there.